Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullahi wa barakatuh. In this video, I will show you on the topic of hyperbola. We will go through the basic of hyperbola, the graph, the equation, and last but not least, the examples of hyperbola. Let us look at the basic of hyperbola. So this is one example of hyperbola with our transverse axis parallel to x-axis. So the first thing that we should know is, for hyperbola, we should have a transverse axis. This is the transverse axis here, where on this line, you have your center, you have your vertices, and also you have your foci. So we call this transverse axis as parallel to x-axis because it is a horizontal line. In ellipse, we have major axis, but in hyperbola, we call this as transverse axis. The second thing is, we should have a conjugate axis. So conjugate axis is the opposite of your transverse axis going through the point of center. So this is your transverse axis as if your major axis in ellipse, and this is your conjugate axis as if your minor axis in ellipse. Next, you should have your center. So as usual, our center point is the point at the middle here. So I label here as center. Then let us look at the shape of your hyperbola. So since your transverse axis is parallel to x-axis, therefore our hyperbola will open to the right and also open to the left. Let's see here, for the point that you cut through your transverse axis, that is our vertices. So you have 2 points of vertices here, so you can call this V1 and you can call this point as V2. So finish discussing about vertices. Let's discuss about foci now. So as usual, focus must be always in front of your vertices. So since this is one of the vertices, open right, therefore in front of the vertices should be your foci. So let's see here another one. This is one part of vertices opening left. So in front of your vertices, you should have your foci. Last but not least, let us discuss on your asymptote. So what is an asymptote? An asymptote is a line where your graph cannot cut through it. So it will guide your graph to open right and open left, so without going through the point. Okay, so this is your asymptote here. This is a positive slope, and this is another one. This is a negative slope. So how can you get the line of asymptote here? So it's very easy. So it's very easy. Let us look at the distance first. So center to vertices, as usual, this is A. So let me write here, center to vertices, this is A. And then center to foci, this is C. This is similar with what we have done in ellipse before. So center to your foci here is C, and again center to your foci here is C. So we have found the value of A and also the value of C. Let us look now at the value of your co-vertices. Okay, so what is the distance between center and co-vertices? The distance is B. So this is your co-vertices. There's 2 points here. So this is actually B. Okay, so this is again B. So how can we get the asymptote? From vertices here, go up as distance B, go down as distance B. For another vertices, go up as distance b, go down as much as distance b. And then connect all of this line here to become a square. And then you just connect the side here. Okay, connect them together. Make sure it goes through your center. So connect them. So that is one of your asymptote. Your another asymptote. From this point here, just connect the line going through your center and then extend your line. So that is another asymptote. So asymptote is just a straight line. So later on, we'll see what is the equation of asymptote. So what does asymptote do? So what does the implication of asymptote? It will control the opening of your hyperbola because the graph cannot go beyond the asymptote line. Moving on to another slide. This is also the basic of hyperbola, where the transverse axis is parallel to y-axis. So you can see here, this is our transverse axis. So automatically this will be your conjugate axis. The opposite here, going through your center, this is conjugate axis. So let me label here. In the middle here is C as your center. So this point here that cuts through the graph is V1, also V2. And then in front of your vertex here, and in front of V2 here, this is your foci. So you can write it as F1 and also F2. Now let's see the distance. Center to vertices to distance is A. So let's write here, this is our A. Then center to foci, this is C. Okay, so center to foci, the distance here is C. So for the next one, we can now find our asymptote. So asymptote is associated with our co-vertices. So the distance between our center and co-vertices is B. So let's see here, from our center to a distance of co-vertices is distance B. So let's write it here. It's two distance here. So from center to co-vertices B, from center to another co-vertices is B. So how can we find the asymptote? From our vertices, just go to the right and go to the left as much as distance B. So from vertices, go to the right and go to the left as much as distance B. Then connect this edge here to make a square. Then connect these two edges here, connect them, make sure it goes through the center, and then extend the line. So we have found one of the asymptote, which is the positive slope. Let's see another asymptote. So connect these two edges here, make sure you make it go through the center, and then extend the line. So now you have found another asymptote line, but now it is negative slope. So the reason why we draw the asymptote here, because we want to control the opening of our hyperbola. So that this is our hyperbola here. You cannot touch the asymptote, but you can just approach it. So from the vertices, you can draw another line of your hyperbola. Make sure it doesn't touch your asymptote, but it will just approach. So now this is the basic graph of hyperbola with your transverse axis parallel to your y-axis. So this is the end of the first part, which is the basic of hyperbola. Let's meet at another video with the topic of graph. Assalamu alaikum wa rahmatullahi wa barakatuh.